Welcome. My name is Chris. I'm a senior solution architect here at Amazon, and I'm excited to talk to you today about unlocking peak performance with Vega Developer Tools. So before we dive into our tooling, I wanted to level set a little bit and talk in a simplified version about the React Native rendering. When we look at React Native rendering, it follows a declarative approach where the UI updates in response to the state and prop changes, right? So it uses a virtual DOM or a virtual DOM-like system to efficiently compute differences and apply updates. So if we look on this graphic here, what that means from top to bottom is from our JS thread, it would handle the logic and state, while a separate native thread renders UI components. And using platform native APIs, we have a communication or bridge layer where, for example, newer architectures would use the term like Fabric here that you might know from stock React Native. And it improves performance by reducing its overhead when we use Fabric there. And our third layer, which is the bottom one, which we also refer to as like the native thread, this is where memorization happens with the native driver for animations. And it also helps improve efficiency by minimizing unnecessary re-renders. So that concept is important to keep in mind when we talk about app performance in general, because as we send these UI updates for our bridge layer and we translate that to native API calls, we're also able to receive the feedback with events from the native thread to the JS thread. So what does that mean for the world of Vega Developer Tools? While we support standard tools like, for example, React Dev Tools, we have our own set of tools that we would like to present today as part of this series. We'll look at the KPI visualizer, we'll do some activity monitor runs, and we'll also look at the library called YDD-render that works with Vega, where you can understand why an app is slow. That being said, we also support standard tools out there like Flashlight, for example, Perfetto for log traces, the React compiler, obviously, Charles Proxy, Reassure, which is another library from one of our partners to measure app performance, and so forth. So one reminder, performance is a journey. So what does that mean is don't give up. While you're optimizing for performance, you follow through the natural cycle of root causing, you're doing improvements, you measure stuff, you follow best practices. But we also give you tools like the KPI visualizer or the activity monitor. And to look at a more concrete example, we've intentionally disrupted move performance in the following app to highlight the rendering and inefficiencies. And our goal here is to identify unnecessary rendering cycles and perform performance-heavy functions. So if we look at a bad performing app, you will see the lag here is created on purpose with some heavy code that we've implemented. It's clearly not a great performing TV app. It actually happens to be rejected by our internal team for our store. So one of the things we can look at here is using KPI Analyzer for our VS Code plugins. And we're opting for not recording the CPU profiler because we don't need that. And in order to have consistent results, we're using something called Appium, which allows you to step through your app step by step and prove, so to say, consistent results. And as you can see, the app fluidity is pretty bad. It's a 78 score. So let's look at this a little bit closer. Let's use YDD-render. And we've prepared a file here where you can actually see its configuration. We only run this in development mode. That's very important here. And we want to also trace certain hooks, and in order to run that efficiently, once again we have to rebuild the app in development mode. And while that pops up, what you will see shortly on the screen is essentially all the hooks displayed that cause potential re-renders of the app. And now we can step through and take a closer look on why that is the case. Also important, we want to switch from the display of Kepler logs to actual React Native logs so we can see what's going on in the app, and now start navigating on the app, and then you'll see certain hooks that are happening, right? So for example, it's re-rendered because of these changes. And what we'll start looking here specifically is two functions. We'll look for useState and useSelector. And as part of this examples, what we'll start seeing is how we can debug useSelector itself. It's a little bit hard to see sometimes in YDD-render which function you want to actually target, but since you've usually written your own code, you know where to look. So, for example, useSelector here, we know it happens 3 times currently, and we also happen to identify our code already in this file, where we know on the click count we've used useSelector, and therefore we want to change that. So an easy fix is obviously removing it, which for this example will prove the scenario that it actually will be removed from our re-rendering cycles as well. And we just come up with a simple dispatch increment to not break our code. And as you will see, when we start rerunning YDD render, like the use selector will actually disappear. And we're going to look at that in a second. So now that we're zooming out again, we're navigating, we're rerunning the app. And on our YDD render, there's no more use selector to be found. And that is actually very nifty. That way you're able to identify, do I do unnecessary re-renders, and so forth. So the next one is hot functions. Hot functions is a really interesting topic because it's something we provide through Activity Monitor. So it allows us to, one, analyze what's currently going on from a memory and CPU standpoint, but we can also like start a recording. And there's two ways how you can start it, either by right-clicking on the device like we do right now, or we are the Command-Shift-P in VS Code. And now let's start the recording. You'll give it a name essentially. And as soon as we have given it a name, the recording will happen in the background. We start clicking around in the app as much as we want to record. When we hit stop recording, it starts saving it and shortly should open it and will show us what we're dealing with. So right now we know there's an unfocused rendering function that we're looking into right now that just takes up tremendous amount of time. So if I just get rid of that code piece, just to show you that example, we name it again. So once the app is relaunching and once we start navigating, our recording is therefore still running, and we can hit stop and we will see that like the hot function that we identified essentially like disappeared. Now we're not having like the hot function anymore that we're dealing with. So now that we've done the fixes with YDD render and we removed certain hot functions, we're able to see now that through the KPI analyzer, our numbers actually have improved. So now we're able to like hit 99 versus before it was like 78 or something like that. These are really powerful tools within Vega Developer Tools that we're excited to get in the hands of you and that you can actually try and see what's going on in your app. In case that was all a little bit too quick, we have it all documented as part of our documentation. We also have now a frequently asked questions for app performance issues. And that was it. Thanks so much for your participation in this video about the overview about our KPI tools or KPI Analyzer, Activity Monitor, and how to monitor memory consumption in our apps. And I'll hope to speak to you soon. Thank you.